Python string, we have already, I think everybody has some familiarity with a string, and a Python string, as we have already seen, is a sequence of characters. Okay. The important point with these strings for performance purposes and many other purposes also are that they are immutable. That means once you have a string, you don't really manipulate the string. You create a new string when you try to do something, which you will see soon. So let us look at it. Let us define a string. H equals to hello world. So this is my string, the first Python string. I can execute it. I can do Python type of H and type of H, and it will tell me that it's of class str. Okay. Now in Python there is also a module which you will need actually, which is called string module. So if you want to do operations on the string, you have to import the string module, and for that you can say import string. So you do that, and we have seen that Python has a very powerful mechanism of knowing of what a module can offer. So in order to look for that, we do dir and name of the module. Okay, and this dir can be applied to many more things other than the module also. Okay, so if I do that, and then I will see that the module has got a lot of stuff, but here I don't think we have something that we may be using, we may not be using, and so on. So this string, just hold on a moment. I think this one is different from, once again, from 2 to Python 2 to 3. Certain things are different. Okay, so for example, my old lecture note tells me that there are a lot more stuff in the old Python string module, but now we see that they are less. So let me check the object dir of H and see what happens. Okay, as I said, dir can be applied also on the object, and here probably I will get more stuff. Okay, so here you see now that instead of module, so it changes from Python 2 to Python 3. Several things have changed. So for example, in the case of Python 2, we were talking about the module and lot of facilities coming from the module. In the case of Python 3 now, they have removed some of them, many of them, but those facilities are now part of the object. That means if you want to take some action, you take the action based on the object. So we'll see that, but at least you know that if I do dir of string, I get certain facility which are not so many. But if I do a dir on the H, which is a string object, I see a lot of stuff. Okay, and some of you who might be curious to understand what they are, I told you that all the languages, object oriented languages, they provide a facility called operator overloading. Operator overloading means you try to use more familiar notation to operate on some object. For example, for the algebraic object, if you have a 4 vector, you would like to do a plus b equals to c. That means 2 4 vectors you can add to get another 4 vector. Now if you want to do it programmatically, then you have to call some function, either a function from a module called add a comma b, or you could say a dot add b, etc., etc. But these languages, Python, C++, etc., they also provide some high level notation, so that you can simply write a plus b, and this plus will actually invoke some method which is already defined here. In this case, for example, a plus b, in the case of a string, will call add underscore underscore add underscore underscore. So this is also another important convention, that Python does not hide anything from you. So it goes by convention that some function name which starts with 2 underscores and also ends with two underscore are really something very special to the module or to the of the class itself. You should not redefine them. You should not even touch them. So this is very important. Although Python doesn't really prevent anything. That means in principle you can redefine minor underscore underscore add underscore underscore to something else, in which case it will totally fail. So you have to be respectful about this convention, that if there are this underscore underscore stuff, this means that I should not really redefine them. I should use them following the rule that Python has laid out. Okay. Similarly, if you have two strings, if you want to compare the equality of them, so there is a function to check whether the two strings are the same. But because of the operator overloading, you can also say if A is a string, B is a string, A equals to B, or A is B, or A is not B, etc., etc. For that also you have to uh, you have to overload the operator like the EQ if it is greater than equal to GE, and so on. So all these things are very special functions, and most of them actually are used for operator overloading. And after that, after those very special functions, you get the normal functions. Okay, normal methods. I do not say functions. So if I give you a string, I can check whether it's alphanumeric or whether it's digit, whether it's ASCII, and so on. All of those you can check. For example, I could easily check with my age dot is digit. Okay, so I would do like this. So H is hello world. It's not a digit. And if I check is digit, it will give me false, and it is giving me false. And now by now, I think you have already understood the way we use a function. An object. So if you have an object, and if you want to act on the object, the notation is that object dot and some behavior, and the behavior will be defined here. Okay. So if you want to make, for example, age upper, and you see that hello world becomes upper hello world. Okay, but this one doesn't change the age. Now let us first of all see whether I can at all. So if I have a age which is hello world, firstly I say this is a sequence of strings. So let's do one thing. X in age, this is my string. I can do print X. Okay, so i can actually I can actually iterate over them, and I get individual strings. Okay, this is the first thing that you will do. So if somebody gives you a string, you know that it's a sequence of characters. How do I know that? So you can check whether I can iterate over them. Yes, I can iterate over them, and I will print each character at a time. Now the immutability from the definition. Let us say if I do h0, that means I'm now trying to replace the first character and see what happens. Okay. Sorry, my hello world is with capital H. Now let me see. I want to change it to small h. Whether I can do that. Okay. So if you do that, and you see that it's an error, because the string object is an immutable object and it does not support item assignment. Okay, so it tells you that the string object doesn't support item assignment. It's not like list. Okay, it's not like list, in which case actually you can change the value of individual elements. Okay, what happens if you do that is a different issue, but at least you could do that. But in this case of a string, you cannot do that. So whenever you operate on a string, actually you create a new string or new substring and so on. So this you have to keep in mind. Okay, now I will go back to slides again, because I don't want to actually. So this slide is now useless, as we have seen. This is again probably Python 2. Now let us again have this hello world. And as I said, we have already seen many there are many methods which are supported for a string object. Okay, so I mean, which are they? One we have already checked, whether it's a digit, whether it's a digit or whether it's space. So there are many things, as we have seen. We can check once more here. You see that if it is a digit, whether it's a decimal number, whether it's lowercase, whether it's numeric, whether it's printable, whether it's space, that is empty space, whether it's upper, etc., etc., whether it's ASCII and stuff like that. So lots of stuff. You can all check all of them, all of them, because of the naming convention. You know that they will return a Boolean information. Okay. Now, for example, another little thing which you can do. Let us go back to our another. Let us say I have another string which is the same hello. Now I put a tab here, world. Okay. So the difference between the other one is that in the first case I had hello, then a space, and world, and now I have hello followed by a tab, backspace T, and world. So if it is only a string, that means if I simply print the string, then that will be a literal. That means the backspace T will come like that. It will not be interpreted. It will not be interpolated. Okay. But if I do, I have to just check the name once more uh, from here itself. Expand tabs. Okay. So there is a method called expand tabs. If I do that, okay, and you can see now the difference, that this backspace T now is acting as a tab that you actually press when you write Python. Okay, so these are the facilities which are all there in the Python string, not string module now, and not anymore, with the Python string object. Okay, so there are many more. We have already found one which is called art strip yesterday. We have actually will now you can check. For example, you can check whether this S or H, whatever, starts with hello. Okay, so let us say whether it starts with hello. Okay, so this should be true. So if you do that, sorry, so these names are not really starts with, or all small, not this one. Okay, so you see that it's true because it starts with hello, or it's ends with, so ends with something like hello. So this should be false. It is not there. But if you do s ends with exclamation, then it should be true, because in fact it ends with exclamation. So all this stuff are there. The most important point with a string we have already discussed. I want to just repeat: a string is immutable. So if whatever I do, I am actually creating a new string. So and whenever you create a new string, if you do it on the fly, then that creation is always optimized. But if you store them in memory in Python, so I mean, whenever you have a string, you operate on the string and you get a new string. Now you assign that new string to a new variable, and then you work with that. So that new variable will continue to stay there as long as the garbage collector feels that it should be around. But if you don't assign them to a local variable, the output of the string operation, but you can do it on the fly, that means there is no named variable at all. So the memory will be allocated and deallocated when the operation is over. So this is a very intricate point of with any language. That means you should work with the temporaries on the fly, and not assign the temporary to any local variable, because then either you have to delete them, or they will be deleted when Python garbage collector thinks that they can be reclaimed. So during that period, that variable will unnecessarily be taking some memory. So all the operations that can be done on the fly without creating any local variable, temporary variable into local should be done that way. Okay, and so that if you have a long operation with string, you still will try to do it on the fly, so that there is no temporary created at all, okay, as a local variable. Fine. Now go back to slide again, just to complete these things. So some of them I have seen starts with we have seen, then the expand tabs we have seen. Now the swap case, the name is very clear that if you have hello world here, and if you see swap case, you can see that it will swap the case of each letter. Okay, so capital H will be small h and so on. You can also do replace. You can also do replace. Now, one thing that is very important is that let us do a replace. So this replace, of course, will be you see that this one is a very important one. This s dot replace. Let's do it. Let's do it here. So s dot replace, and we do replace world with globe. Okay. So we do that, and we print s. What happened? No, sorry, something is wrong. World, capital world, not this one. Okay, so you see the point that s dot replace world with globe actually gives you hello globe. Then I'm checking whether I have changed the s. I have not changed the s. So let us do one thing. Let us see whether I return something. What happens to this? Print type of this. Print type of this. And you see that this is also a string. Okay, so if you replace s, actually, although we don't look at the return type of the method, but actually the return type is also a string. So I can assign it. I can assign it. Let's say I call it s1 equals to this. Okay, and then my s continues. My s1 now is a new string. So this is what I say, that the string, the original string is immutable, and when you do a replace, actually the replace will return the change string, but the original one will continue to be the same. So there is another function, inbuilt function in Python, which will sort of, I mean, don't ask me the detail, which is sort of gives you the pointer. If you think in terms of C, pointer or the ID of each variable which are in memory, which can also tell you whether two variables are the same. If they have the same ID, then they are the same. If they don't have the same ID, we can assume that they are two different variables. So I can do ID of S. ID of S is one value, and from the very big value you can see that it's like a pointer, and ID of S1 is another number. So we can see that S and S1 are actually two different memory locations. I'm not really discussing memory locations, but you get the idea that if you have a memory location, okay, and then you create different variables will be created at different places in memory. So each of them will have some memory location, and in terms of C or C++, they are called the pointer to the original variable, and these two memory locations are are not the same for the two variables. So you can check that. So ID is if you check, I don't know whether I have the help here. I can check. No, ID. Okay, so help on built-in function ID on module built-ins ID and pass the object, return the identity of an object. This is guaranteed to be unique among simultaneously existing objects. Okay, And if you, as I said, if you really think in terms of C, on which Python is based, then it uses the object's memory address or memory location. So it's like a pointer, but we don't talk about the pointer. But we can always check, given two variables, we can always check whether they refer to the same thing. Now you will get a lot of surprises. You will get a lot of surprises in Python where you will actually look around the ID of individual variables. And this is slightly out of context for this discussion, because this is more involved and I need preparation and individual examples to do that. But you will see that Python actually wastes a lot of memory during the operation. And this is how it's not a very nice language to work with. I mean, almost all the interpreted languages, they are really not very careful about the memory usage. They just keep on using new memory, hoping that whatever is not needed will be taken away by the garbage collector. Okay, so if you check ID, so let us check one more ID, although I will not really defend myself. Let us say L equals to L equals to, let us say, list of range of 10. Okay, so you can always look at the print ID of L. Okay, and you see some value. Okay, you see some value. This is, as I said, is the memory address. Now I know that if I print L, I get something. So I do let's say sixth element equals to seventh element equals to 100. Okay, and then I print L again. So you see 100 somewhere. Now let us see what happens to my print statement. Does it change? If it changes, then it's a big problem that I have a list. I have a list with some ID which is unique. Then if I, so it doesn't change. So this is still unique. You see that these two lists are still the same. That is what I say, that lists are not immutable. They are mutable. That means given the same address of the list, I can now change the element of the list. I can, if I do, so you can always check if you are in trouble, if you're in doubt. So I can do append. Let us say I can do 111. So let's see what happens. So L is, now I have another extra element. Then I can again check the ID. Okay, and you see that still the ID is the same. So we are still working with the same object. In the case of string, it is not the same. Okay, because whenever you operate, it actually gives you a new string. So the IDs are different. Another interesting point, just as an aside, will be to understand what is the ID, of individual elements. For example, L of 6. Does it also have an ID? Because it's also a memory address. I can somehow refer to that. So in principle, it should have an ID as well. And that ID will not be the same as the ID of the list. So each individual element of the list will also have some ID. In the case of integers, it's very, very trivial. So it's a lot of wastage. But think about a list where each element is an object which may contain other objects, and so on. In that case, you really have to track the hierarchy, and each individual element should have its own ID so that I can track them properly. I can get the element from the list, and then I can go inside that element, which is an object, and so on. So it is a very, very elaborate discussion about how Python maintains the uniqueness of each object, and while doing so, whether it's really frugal in terms of creating new memory, okay, and forget about it at some other point and let the garbage collector collect it. So I'll not go into further detail, but if you are curious, you can actually check all of them. Okay, so Then comes the two things which you will use all the time. One is a string, and let us say I have this string. I still have H, hello world. I want to check whether there is a capital W somewhere in the string. Okay, so I'll do H dot find, and within quote I'll just put W. So if W is present somewhere in that string, then it will return me the index of the position. So it returns me 6 because hello 0, 1, 2, 3, 4, 5, 6. At the 7th position, I have W. Okay. So it's a Boolean. If I, once again, I check, not a Boolean, it's an integer. If it finds, you can also do R find. You can also do from the other side. Okay. R find, the same thing, and it will again tell you. But if in case of the R find, it doesn't start from 0, it starts from the number. So 1, 2, 3, 4, 5, 6. So on the 6th position, you have W. So you have these two, find and R find. This is find and this is R find. So we have already checked all these things. So the last one I will again, so replace, you have already seen. Swap case, we have upper, lower, etc. We have seen. So last one is split here, split. Okay. So if you have split, you also have its complementary called join. So there are two more methods which are, and these are the most important ones. One is called split, other is called join. Let us look at some example. Let us take this example. I have a string. I have a string ls equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And you don't think that this is an arbitrary stuff. You may have some data. You may have some data from your experiment in a certain format. Okay. For example, the numbers are, this number could be decimal point number, not necessarily integer. Let us say they are separated by comma, lines after lines of data. But your machine learning algorithm or some other algorithm doesn't expect the input to be separated by comma, but they expect them to be separated by colon, for example, which is the usual case. Then you have to actually convert the whole file containing your data from comma to colon, okay, or whatever, semicolon. In case of comma separated value, they accept either semicolon. You know that in the comma separated value, you can also specify which is the delimiter or separator. But maybe in some case you have either space. Okay, so you have to remove the comma, for example. So how do you do that? So you have ls. So I can say ls is my string. So I do ls split comma. If I do that, then what happens? The string, the whole string will be split against the comma as a separator, and they will be put into a list. Okay, so let us, if I do that, you will see the output. The output is a list. You remember, it's a list of characters now. It's a list of characters. It's a list. If you are not very convinced, that I can also first do print type of this, and you see that it's a list. Okay, and if I simply do ls split, okay, so this is one thing. Now let us say I save it. I save it in ll. Okay, so I know that this is a list. Now list, the string has a split and the complementary is a join, but the join doesn't belong to string, of course. The string join is slightly different thing. This join will come from, no, this also is a part of the string. Now I want to join the individual characters with a string called colon. So how do you do that? So in Python has a slightly awkward syntax here. So I'll put a quote, I'll put a colon here. This is my string. Okay, this is my string. and then I say join, and I put LL. In other languages, I think it will be more readable. I mean, it will be more accessible, more readable to you if you had a function something like this, that join, where the joining character is colon, and you give the input list. But Python does in a slightly different way, because the join is a method of the string itself. So you first put the string. Okay, now you can see that even with a string literal, because it's an object, you can even on a string literal, you can call a method. So that's interesting. So on a string literal, which is a colon, and I mean they are within a quote, it becomes a string. Python considers temporarily. You don't have to assign it to a variable. Python will on the fly assign it to a temporary variable and call a method join on that object. And what do you get? What do you get as input to the join is a list. Okay, so this is something that you can find out. So you can see that now your string, which was 0 1 2 etc separated by comma, now again you have 0 1 2 etc by separated by colon. Okay, so you can actually combine all these things into a single line, which usually when you write real code you do. So you say that if I have ls as the original one, then I will have ls, then split, comma, and then I will say so this is your single line. Okay, so if you now read from right to left, so from right to left, you first take ls, which is your input string, you split them against comma, which creates a list, and then once you have the list, you have this line essentially. You have this line. So you can also do this. You get the same result. Okay, so I mean, it is needless to say that string is a very important element in any programming language. Okay, so you have to learn about string. You have to learn about string manipulation. So in Python, there are few things which you should know. In the first slide, I have this. So a string could be within double quote. Okay, in Python within double quote. A string also can be within a single quote, and Python generally doesn't distinguish between the two. It will consider both of them and in the same way. Okay? One very important thing is that with a special syntax, a string can span multiple lines, and usually Python uses that syntax as a document string. So in a Python program, if you have something like three double quotes, let's say, and you end with three double quotes, and within that you can write anything. And Python, you see that there is no particular syntax. Python will consider all of them as comment line, and some Python will also consider as the documentation string. If you put it in a module, if you put this in a module and the beginning, Python will consider. So if you happen to look at some of the Python modules, you will see that the document string is usually given like this. So it has, in some other languages, shell scripts, etc., it has a different name also. It's called a here document. Okay, but let's not really go into that. So Python actually can have multiple the comment line, which is can span multiple lines. Okay, and you see that here I can even assign the whole thing to a variable. Okay, so I can say c equals to, then I put a quote here, I triple quote, I end with a triple quote, and I put whatever I want to do in between. So if you have some data which you want to if you don't want to put in a separate data file, but you want to put them in your Python code itself, maybe 20 lines, 50 lines of data, you can actually put them like this, that my data equals to triple quote and triple quote, and within that you do whatever you do. you want to do. So your data is now a string. Okay, then you can split the string against a new line, or then you can loop over individual lines, again split them against any other character or space, white space, etc., or tab or comma or colon, etc., and you can grab all the data individually into a single list in a single stroke. Okay, so this is something you should remember. And the other important point is that sometimes you have I mean, you will probably not do it by yourselves, but there are quoted string. For example, he asked, then see, he asked within double quote, which is your favorite team? Okay, so you see that now if you want to use double quote in Python, there is a problem, because even the string literal which you got from somewhere also has double quote. So if you put them inside double quote, then the string will be from here to here. It will so let us remove this for the time being. Okay, so I'm putting them inside a double quote. So the string will be, Python will consider this part to be the string, and the rest of the part will give you some kind of syntax error, because it doesn't start a string. After a string is closed, it is something else. It will say which is a variable which is not found. If you want, I can show you. Let us just copy this and see whether I can print it, and which kind of error it actually gives me. And you see that it gives me an error. So invalid syntax. Perhaps you forgot a comma, etc. Whatever. So, but it doesn't work. But how can you make it work? Then you have to escape. You have to escape the string which is embedded. That means the first one, the first and the last quote, double quote, is to specify that this is a string, and the ones inside are the embedded string. So I can escape the embedded string with the backspace. If you escape them with the backspace, okay, and do it again. So I will put them in a different line. So this one. So how do you solve it? So one way to solve it is to backspace, put a backspace here to escape it. Okay, so you just escape the double quote, and you see that now it works, and it also shows you correctly the literal quotes. Okay, the other option is not to use double quote to specify the string, because I told you that both double quote and single quote will work. So if instead of double quote, if you now use single quote, then it should work. Then you don't have to even escape it, because the double quote and single quote are two different things. So the literal string is within a single quote, so the literal string will continue to work. So it will continue to work. So this you should also remember, this one. I mean, whenever you write Python, you should remember. So let us go very quickly through the slides. I think I have covered most of them. So this we have seen. Okay, formatting, I think you all know to some extent. Python formatting now has an old way and a new way. The old way is called the C way, which is called with the printf like syntax. So for example, if you have a literal value which is 50.462, let us just copy this and print it. Okay, so if I have a literal like this, and I see that it prints, because I have not specified here, I have given Python freedom to choose the number of points after the decimal, positions after the decimal. So by default, it actually for floating point numbers, decimal numbers, it shows 6 digits. Okay, but if you want to show only 4, then you have to specify that in formatting. So what you will do is probably you say 0.4. Okay, and then if I print it, and you see that I do 0.4. Okay, similarly for other stuff, I think this you all know. And if you want to put a plus sign here, you can put it. If you want to make more, like if you have 50.46 but you want to, you have a column of values which you want to actually align properly, then depending on that you have to change the format. And I think this you will understand by yourselves. Okay, so it's not a big issue. The other one is the new formatting style. Okay, we so called modern formatting style, where it is important to understand that now the way you look at it is totally different. Now the format is a method of a string. So first you have to put the string. Okay, but where do I get the string? I don't have the string, so I will make the format statement to be my string. Okay, so again it's a little bit funny, like the case of join, where you first put the colon within quote, which is your string, and on the fly you call the join method. Similarly here you will call the format method on the fly, okay, based on a literal string. So for example, this one, if you want to format the pi value. Okay, fine. So let us take it and try to explain it once more. So, so import math, okay, and you see that now I am printing the value of pi, and I am formatting in such a way that it shows me 3 decimal points. Okay, how do I know where to put that 3 decimal point? I don't have a very easy way in this modern signature. In the case of the old one, I could do that. I could simply say print, and I would give the formatter thing, which is the format itself, and then after the percentage I give the value. So in this case, so let us put side by side. So in that case, it will be like, so import math, I'll put it, then I will put another cell below or above, sorry, above, and I'll put, let's say this one, 0.3, and I'll put math.py. Okay, so not to get price, I'll say pi equals to this. Okay, so here things are very straightforward, that you have a print statement, there you have a string where inside that string you specify the format, and you can add any other string. I have added pi here. Okay, then you put the percentage mark, and then you put the value. Okay, and here there is no method. There is no method here. It's just a basic function with a particular syntax. So if I do that, it printed pi equals to pi colon 3.14. So here, how do I achieve that? Exactly the same thing I can do like this. But you see that this is a string, this is a literal string. They are delimited by 2 quotes. Okay, this is a literal string, and then on that literal string I am actually acting on the method called format, and within the format I am passing the original value. So they are two totally different way of doing it. There are advantages and disadvantages of both of them. Okay, what is the advantage? I'll show now. The disadvantage is that you have to get used to it. Once you get used to it, probably there are not so many disadvantages. For example, if you have, let us say, another one where you say pi and you say log of 10. Okay, so how do you do this? So this is sorry, does it work? That is the question. Pi equals to this, and this worked. Now if you have if you have more than one such formatter, how do you do it? Let me go back to just to check, make sure that yes, it can be done. So you have, for example, this one, and you can have many of them, both delimited. So I can do it. So this is one. Then I can probably put a comma here, and I can put log of 10 equals to another such formatter, colon log of 10 is whatever. I can put 3f, and then how do you put it? You can see that I have put, just here I have put one, but here I can separate it by, separate them by comma. So I'll separate them by comma. Format, let us see whether it works. Format by format math of log of 10. Okay, so it can be done. So it is a matter of getting used to it, and then it will work. Okay, now what is the advantage compared to the old way? So as you can say, if you want to do it in the old way, you will, what you will do is the following. What you will do is the following. You will not use this. You will not use this. Instead, you would use this one. Similarly, you will use this one, and then after that you will use this, and you have to put within a bracket to signify that it's a tuple. It's a tuple. One. Okay, so this one. So this is the old way. I hope this works, and this works in the same way. Okay, so it's up to you. Up to this point, up to this point, it's up to you whether you will use the old way or the new way. But the advantage, slight advantage of the new way is that you can also use either index in case of list, or vector, or the dictionary key in case of dictionaries in the modern way, and not in the old way. In the old way you don't have that option anymore, but in the new way you can do that. And also there is another very important advantage of the modern way, is that a single number can be formatted by using format specifier many times, in many different times. So you see that I want to print a value 21. Okay, I want to print a value 21. So I have only one such format. Okay, the method inside the format method, I am only specifying the value once. But in the format specifier, which is a string, I have specified four formats. I have given four format specifiers. So this number will be printed for each specifier. So it will be printed for this, and this. So there will be four such things. So this to me is a clear winner in case of the modern syntax. Okay, so if you have if you have a value 21, you want to print it in terms of decimal, you want to print it in terms of hexadecimal, octal, or binary, all you have to do is just give the format specifier 4 times, but you don't have to say like this. But if you have different values, let us see what happens. Okay, then you will have different values. Okay, then also it will work. If you have the same value, you just want a different representation, then you have to specify it once and not 4 times. So this is a clear advantage. Okay, no, it looks like that is not the case. You have to it shows me the same value for each of them. So in that case, because why is that? Because I never tried it out myself. I only tried this one. So this is certainly advantageous that you have only one value. But here, if I put other values also, okay, this I have to check. And if I put other values also, it doesn't take. It only takes. Oh, sorry. Now I understand why. So this one will have to be like this, because this is positional also. Okay, if you want, so what happens is that you do decimal for 0, which is the first one, because this is like a tuple. This is a tuple, and this is the first one, this is the second one, this is the third one. So you see that now it will change. So you see there are power. So here on the other hand, you have only one element and you have put 0 everywhere, just to specify that from the tuple you take the first element and you format them in 4 different ways. And if you have different numbers in a tuple, then you have to specify 0, 1, 2, etc. The positional arguments also, and it will correctly do it. And then similarly, for example, you see that I prefer, let us say there are you know that there are editors like VI and Emacs, etc. Some people prefer VI mostly, and some of them, like I do prefer Emacs. Okay, so if I want to print, if I want to format a string, instead of printing I just want to save it in a string, that I prefer Emacs over VI. Okay, how do you do that? So here for the time, because you are not really formatting a floating point number, it's just a string, you can also use the positional argument like I did earlier from the tuple. So I simply say within this format specify 0 over 1. So when you, so if I do that and I print s, if I do that and I print s, okay, you see that I prefer Emacs. But if you, on the other hand, if you do the opposite, that should also work. That should also work. Okay, I prefer VI over Emacs. If you instead, if you say, then you 5 over 1, so then Python should really give you an error that replacement index 5 out of range for positional argument tuple. So this tells you that this is a tuple. I mean, first of all, this is a tuple. So whatever is the input, the data type which the format actually takes is a tuple. You remember that either it can be a tuple with arbitrary length, or it can also be a key value pair with arbitrary length, because it's a function, it's a method, but it's a function. And we said yesterday that a function can take arbitrary number of arguments in terms of a tuple where you put star arguments, and it can also take an arbitrary number of key value pairs where you will put star, 2 star, and then argument. And this is what you can pass one argument, you can pass 2 arguments, you can pass any number of arguments, and then you work there. So let us say if you have for example, what will happen, so let us put another one, pico or nano. So third one. So you have a tuple with 3 elements, but here in the formatting you are not using the third element. Will it harm? Probably not. Let us see. It doesn't really harm. But if you, we have already seen, if you don't have the element here and you want to, you put something which goes past the size of the tuple, then it gives you the out of range error. Okay. And similarly you have the key value pair. Okay, key value pair is, you can say lang whatever, then within the format specifier you can just pass the key. Here you are passing the index, now you are passing the key, and you are now passing to the format method the key value pair, arbitrary number of key value pairs. So that will also work. Okay, so these both of them are the same. So this is string formatting. I think it is more or less done. Now I will move to input output. Input output in any language is very important, and we know that in Python also it should be equally important. And in Python we have already seen that we have one module, very basic module called sys, comes from the name system. So you can import sys, and if you do a dir of sys, you can see what happens. I am so import sys I am assuming that you are following everything because I don't hear any question from you. So this is something a very very long one. You don't really need to know many things, but at least for the time being, you need to know three things. One is called std in, the other one is called std out, and the third one is called std error. So in, I think in the operating system, let us talk about Unix. You have three input output streams. One is called the input stream, the output stream, and the error stream. So if you print something, you can print it either to the output stream or to the error stream. You can choose. When you read it, read some input from the either terminal or from somewhere, this is an input stream. So input, so std in, std out, and std err. Now what you can do, so you can check what I have done here. So you can look at the type of std in. Again, from Python 2 to Python 3, a lot of things have changed. So I have to do so because I have imported the module std, not std, sys, and std in. I can look at the type of that, and it will give you something called text IO wrapper. So this is my class, okay, and it is a part of a module called underscore IO. And from this underscore, you now know that it's a very special thing. I should not really play with it. And the name of the class is, again, it's not very important for you. And all the three we can check, all the three: std in, std out. Okay, it's another one which is called outstream, and what is stdr air. Std air is again an output stream. So there are two input, one input stream and two output streams. So what was there? Okay, so you see that something has changed again, or this is wrong. So I have to make sure. Okay, so this I'll correct, and then, so important thing. Sometimes nowadays most of you will always use the Jupyter notebook, but think about old times, or even today you can do it when you have to go to the Python shell. In the Python shell, you are doing something, okay, and there is a lot of output which are printed, and you want, because they are printed on the terminal, because your std output is defined like the terminal, so they will be printed in the terminal, but maybe they are useful stuff. So after your session is over, you have to copy it and paste it in a file. What you can do is that you can redefine your std output in such a way that they will automatically, whatever you do, they will automatically go into a file. Okay, so this is a trick that we used to play earlier. So redirect your std out to a file. So I will open a terminal and just show it in case someday it is needed. Where's my, okay, so wherever. Okay, so import sys. Okay, so I think, okay, then what you do, I'll just cut. So let us, so if I do print hello world, so it will be printed on the terminal, hello world. Okay, but I want to redirect all the output to a file. So let us open a file. F equals to open, this you know now, open. So output dot text, this is the name I am giving, and then it is an output file. That means I want to write something there. So what I'll do is I'll put a W to specify that it's an output file. It's for the write mode, not the read mode. It's in the write mode. So I open it, and then I directly assign I directly assign sys.stdout equals to f. I directly assign the std out to be the file handle. So this also tells you that because I can assign them the two objects, one object is the f, which is a file object, and the other object is the std out. Okay, they are compatible objects. That means I can assign f to std out, or maybe also the other way around. Okay. Is it okay? Okay, so now let us print it again. Now let us print it again. Hello world again, and see where it prints. Okay, you see that now it doesn't print on the terminal because I have already redirected whatever should be printed on the terminal to a file. So it will go to the file. How do I know that? So let us close the file now. I want to come back to the terminal. So what I'll do is I'll first close the file. To close the file, because file is an object and there is a method called close, I simply call file close. So the file is now closed. Still, if I do once again, what will, now the file is not there. Now it's even more problematic. The file is not there, nothing will be written. File has been closed, nothing will be written on the file. And I am trying to print something else. And you see that now there is a big problem, that the value error, the IO operation on closed file. Okay, a file has been closed, but the pointer still remains from the std out, still wants to write to a file which has been closed. So now the std out is a dangling one. It doesn't point to any valid resource. Okay, so I have to get it back. To get it back, I have to take help from the special variables. So sys.std out, if I once again do a dir of sys, because I have already imported it. Oh, and nothing will happen here. So let's go back to this. Dir of sys. Okay, and you can see that there are two appearances of std out. So one is here, std out. Okay, and this one I told you without any special magic in the name. So this is a public method. But there is also another one, which is a private method, which you should not really play around with. Std out with underscore underscore before and underscore underscore after. So usually when you start the Python session, both of them are the same. And then what you do is you can actually change this. You can change this, which we have done. We have changed this to file. Okay, but you should never touch this one, because this will continue to look at the original value. So now it gives me a chance to come back. So what I will do is now I will say sys.std out equals to sys dot underscore underscore std out underscore underscore. The fact that Python doesn't keep the any private variable, so you can, or private whatever private member, let us say either member function or member variable, you can still access the underscore underscore std out underscore underscore from the module. Okay, in case of other languages you would have to take some other route. Here you can directly assign it. So you directly assign it. Now you do this and you see that again it prints whatever you want it to print. Hello world once again, and so on. Okay, so this is a trick which one used to do a lot of time when there were no Jupyter notebook or even a very good IPython. Okay, but nowadays it's not really used that much, but it may come handy at some point. So now if I quit this, then you will ask me whether that file is there. So output.txt, yes, the output of text is there, and you see that the output of text has one line which was redirected hello once again. Okay, so that's so this is
Sir, can you please again explain the std out and underscore underscore std out? I didn't understand the difference.
okay. Okay, good. So I said in Python the variables or the, let's say, symbols which start with underscore underscore and ends with underscore, the symbol which ends with underscore underscore are very special symbol, special variable. So in the case of the sys module, you see that there are two occurrences of the same name, one without any underscore underscore, which is std out, and one with the underscore underscore. Okay, so to start with, when you start a Python session, they refer to the same value. Okay, if you want, I can even let us. I don't know whether there is a way, but we can say print. I don't know actually what it will print. So this one, okay, and print sys underscore underscore std
Okay.
out, because here I have not changed it at all. Okay, so you see that now they don't actually print the same thing, so it is not really easy to understand exactly what goes on. I can let us see, I can say id, just to know id of this, id of, they are the same, their value are the same, but the id may not be the same. Okay, so the id are also different, but they point to the same value to start with, which is the std out, is that you print it on the terminal. Okay, both of them refer to the same thing to start with. Now this is a private symbol, I should not really play with it, I should not change it at all. And because they have two different ids, that means they are two unique separate different objects. That means if I reassign this std out to something else, this one is not affected at all, because they are two different objects. So what I will do, so to start with, both of them have the same value. Now I change the std out to something else, I refer to a file, and then I do whatever I want to do. Everything is redirected to a file, and at some point I am done. I say that close the file. So the file is closed. Once the file is closed, my std out is still referring to a file, so it's a dangling kind of a pointer, because the file is closed, it's invalid. So what I can do is, now I can come back to my original configuration, and the original configuration is still there in sys underscore std out underscore, because it is not changed, it is still unchanged, and it is still referring to the terminal.
Okay, so sir, is there any other way, like except for, I mean, equating to the underscore version, can we point it to the terminal again in any other way?
I don't know about that. This is the only way I know. I mean, this is the only trick I know, which we used earlier. So if you want to look at the terminal, then you see that the important point is that you are not really, in principle you can define a file handle which is your terminal. Okay, then you can explicitly specify the file handle in order to print it to the terminal. But here you are not doing that. You are assuming, you see that when I say print, when I say print something, I am assuming that it's the terminal. Okay, so in python, where is my python? If I do python, if I say print, I'm not saying that a terminal handle and then my hello world, I'm not saying that. Okay, I am
Yes.
assuming that if I don't do anything, it will print it on the terminal. Similarly, uh, anytime you work, you never had to actually mess up with things. If you wanted to send your output from your terminal to the file, you could do this, you could do like this, that f equals to, I think I have already the example, open again output dot text. Okay, and then you put w, you do that, and whatever you do, whatever you want to write now, I think you could do f write, and you pass your data. Okay, then all the data will be always written to a file. So I just want to work normally, and either the output comes off the terminal or goes to a file automatically. I don't really explicitly want the file handle to to use the file handle. So this is what I say. That's why the trick is there, that you reassign the std out to be the file handle, and you work in the normal way. All the output goes to the file. You close the file, then you come back to your original configuration. So you
Okay.
always have the way. You always have the way to explicitly send any output to any place. But I am talking about implicit way of doing it. Okay,
Uh,
and it's
yes,
just a
sir.
trick which you probably don't need anymore. But because of completion, I wanted to say that. Now this I will not really. So sees like you have the std out. You also have the std in. Okay, for example, this one, if I take this line, again, I don't know whether it will work on the notebook, but it will certainly work on the terminal. So what it will do is std in read lines actually will wait for you to type some lines. Once you are done, you have to press Ctrl D to signify that I have given you the end of my data. So then it will actually read all the lines, split those lines against new line, and convert them into a list. So this is the example that I can show you. So for example, I can again I can do that. So import sys, and then data equals to sys dot std in. Now that means you are taking in input, split sorry, not split, it will be read lines, most likely. Let's forget the name. It's read lines, and you see that the read lines is a method. So sys is the module, std in is the object, and read lines is a method inside the object. And you remember in Python or any other languages, in particular in Python, you have namespaces. Namespaces are equivalent to modules. You can have and modules reside in a package. So you can have a package hierarchy where package A dot package B dot package C, etc. Within that you have a module. Within the module you have an object, and each object has some property. So you have sys dot std in. It's a chain, but it works. So if you press enter now, it waits. It waits. So now you can say 1, 2, 3, 4, 5, 6, 7, whatever. So you do that. It's still waiting for more input, and you say Control D. So as soon as you say Control D, it knows that it's done. The prompt comes back. Now you say type of data is a list. So it has automatically read those lines and split them into a list. If I do type, and you see that 1, 2, 3, 4, 5, 6, etc. with the new line. With the new line, you remember from yesterday's discussion that because each line you have entered return, so a new line was added to each of those input lines. Okay. So then you can do whatever you do you want. So you can, now that you have the list, you can say the length of the data. It will tell you the length of the data, and so on. You can also, in the like I said, in the single line, you can also do something that you want to do. If you want to read line by line, so this one, okay, instead of doing this, if you do sys dot std in dot read, so this will actually read one entry, one line, and you can say upper, because you are reading a string. If you do that and you say hello, and you do Control D, and you see that it has already taken the action, because you read one line by doing a read, and because it's a string has an object, a method called upper, so it has also made it an uppercase, and because you press and enter, it has added the new line. So you see that this is a very important object orientation has a very important and powerful way of operating also, that you can chain. That means if you can design it properly, then the output of one method, or here is a method, will return an object, so that you can actually take another, you can actually act on that object to get to execute another method, and this can go on and on. So if the upper also returns, we know that upper also returns, so we can, for example, upper, and then I can say from upper to is digit, even that should also work. Okay, so if I do hello and we control this, then gives you false. So similarly, you can now chain any number of methods that you want to do. So the important point is that the previous method should actually return to the object that we expect. It cannot return a void or false or something. So only those functions will work. For example, this one will not work. This one will not work. If I now want to do, let's say, lower, this will not work. Why will not work? Because is digit doesn't return the object. It returns a false. That means it returns a Boolean value. So we can check. Okay, it doesn't work because it says the bool object has no attribute lower. So as long as you properly, and I think Python and other languages, the libraries, they try to design it in such a way that in a single line you can actually do a large number of things just by getting calling the proper method of one object and getting either the same object or some other object, and then act on that object and act on another that object in chain and so on. So this is one of the very, very fundamental tenets of the object-oriented programming, which we have not discussed, but you know well in advance. Okay, so eval, again, another very interesting example of eval, which I forgot yesterday, is that you can now take input from the terminal. So let us do it. Okay, let us do it. So this, again, I will use the terminal. So let us say I have string, and there is a default inbuilt function called input, and let us put it like this: enter your input. Okay, so if I do that, it will wait for me. So it waits for me, enter your input, and waits for me. Then I put x for x in range 10. Okay, like we did yesterday. You see that now I am actually passing to Python a valid list comprehension expression. I'm not passing a string. Okay. I am passing this as a string, but this I know that it's a valid Python statement. Okay, so let us see what happens. Let us see what happens. So string. Okay, so Python has accepted it. So if I simply do this, it will show me that string. But if I do eval of string, it will give me the list itself. So this is another example where eval actually shines. Okay, as you can easily see that you can at any time dynamically you can create a Python code and eval it to get some result. Okay. Okay, so this is also done. I think now I have more. Let us. Okay, so now file IO. I will go quickly through them without really executing on the notebook, but I hope you are following it. So let us say I have a file where I have cricketer, the player, their country, their number of test run, and their one day runs. Okay, and there is a list of all the erstwhile players, the very famous ones. And this is a CSV file. As you can see, this is a comma separated file. Okay. Now you will read it. Let us say for the time being, we can do a lot of stuff with that. For the time being, we'll only print those lines where India appears in the next example. and it's very easy. So I'm not really going to execute it for you. So the important point is that you will open the file. And if I call the name, I name the file players.csv, you simply say open, then within quote players.csv. And the second default argument is R. That means it's a read mode. Open it in read mode. For a read mode, it's a default. You don't have to specify it. For example, if you want to write, then you have to specify W. But if you want to read, you can also omit this. There is no problem. Okay, now we know that a file, yesterday we discussed, a file can also be iterated. So you don't really have to open the file, read the lines, and do whatever you want to. You can just directly iterate over the file, and it will give you each line in turn. So that's what I'm doing. So this one here, you see, what I'm doing is that for line in F. So when I say for line in F, what it will do is I told you automatically, it will call read lines, store them in a temporary list, and then serve one item at a time. Because you are not doing it yourself, you are saving some memory, and hopefully there are some optimization also. When the whole file is read, you close the file. Now, line by line, what you do is you strip the in principle, you should art strip only from the right hand side, but you can also just do a strip, okay, on the line and return the output of the strip command in the line itself. Okay, so now there is a very interesting thing. So for example, you see that this line and this line is a string. Okay, so this line is the input string and this line is the output string. Okay, so I will see whether, so this one I will execute, hoping that I am in the right place. Okay, so I should have the players.csv, which is this. So let us do Python and say f equals to open players.csv. Okay, then I say for line as it is written there in f. Okay, so I will simply print for the time being id of line. The first line will be like this. Then I will do line equals to line dot strip, and I will print again the id of line. Okay, and then I'm done, and we'll see what happens. So how it reuses. So first of all, I am printing id twice. Okay, I'm printing id twice, and you see that the two ids are different. They are reused because then Python can immediately reclaim those IDs and reuse it. But the two IDs are different. So this is very important one, that this line, which is an input, and this line, which is an output of the of an operation on a string, actually creates a new string. This is what I said. So both of them are the string, and the variable name wise also they are the same. But if you really look at line this ID and this ID, you see that they are different. That means they are two different objects. And whether within a loop, of course, it looks like they are I don't know really. Yes, they are reused. That is fine, but they are two different strings, and then they are reused. Okay, so this is one thing that I want to mention. Other than that, there is nothing that you should do. So what you do is that once you have the line, after you have stripped it, then you split the line against comma, which we did in another example. Once you do it, okay, I can execute it. There's no problem. So what I do is that I cannot really go out of that. So I will start again, open the file. Then line equals to line dot strip then I can say fields equals to line dot split in terms of single quote. Okay, now I can say looking at the input, if the second element is India, then print. If the second element, so if fields of 1 is equals to India, something like this. So this is as simple as that. So we can see whether it works. It doesn't work. You remember why? Because I have already read the end of the file. So either I open it again, or maybe so okay, I'll open it again for the time being and then repeat the whole thing. Okay, you see now it works. It gives me 3 lines. Okay, so this is simple. This is you will be able to do it without any trouble. Now the question is there are many places where it can fail. For example, the players.csv may not exist at all, and you are opening a file and immediately you are taking some action. Okay, of course, finally when you are done you will close the file, but what happens if the file doesn't exist? What happens if there is a comment line in the input file? You are not taking care of the comment line. What happens if some lines are empty? For example, it could be I mean there will be many uh, places where you have either the comma missing or some field missing, etc., etc. So many things can happen. Many things can, some rows do not have all the required columns and so on. So you cannot really have such a very simple way of looking at it. And finally, you should never forget to close the file if you do it in this way. So Python tries to help you with 2 things. One is that it will allow you to avoid calling, I mean, not forget about calling the close if you use a different syntax. If you use a slightly different syntax, then you don't have to close it yourselves. Okay, so what you can do is you can use this new syntax with open, then players.csv as if. This is a very modern syntax. If you do that, then if f doesn't exist, if the file doesn't exist, it will simply go here. So the first problem which I mentioned is solved. It will, maybe you can print something, but at least it will not crash. It will not give you even some kind of traceback, because it will, this one actually ensures that the file is opened. So if the file is not open, it will not go inside it. If the file is open, then it will know that I have to at some point close the file also. So that also will be taken care of. So now again you loop over the file, you do the strip, and you take care of this. So if there is a hash somewhere, okay, in that line, this hash should not be in any position. We have to see. So for the timing, for simplicity, I assume that if there is a hash somewhere, we remove that line. So then you can do a continue. That way, if there is a comment line, so you should check, you should do a line dot find, then hash, and that should be the first element of the line, okay, in the array. So if that is the case, then you continue, and other than that, you do exactly the same way. Okay, so this is the second one. So it has solved, it's a better approach, it has solved part of the problem. But still, not all the problems are solved, because you should now also check that there are the correct number of elements in the file. That means there should be at least 2 elements in the file. Okay, 2 elements in the file, in each line. Otherwise, you cannot even check whether the country is India. So this I have not checked here in this version. So the third version, is where you use a very high level technique. Now I'll stop in a few moments. High level technique called the exception. Okay, so exception is something where a Python program, whatever you want to execute, will not be executed out in the open. That means it will not immediately give you a traceback. In case of C++, it will not crash, give you a segment fault. In the case of other languages, something else will happen. It will be executed in a sandbox. Sandbox means in a more secure place, which is a sub part of the memory. So that means it will not fully affect the whole system at that point. So it will give you a chance to take an action based of the output of that execution. So it will not immediately take a decision and go out of that. So it will give you a chance to take a decision. And this is called a try. In the case of C++, it's called try catch. I think in the case of Java also it's a try catch. In the case of Python, it's called try except. Okay, that means you have a try block. You have a try block here where you do whatever you want to do. Okay, if something fails, anything fails here, then it will stop the execution right at the moment where it fails, and then it will come here. Okay, it will come here. If you want to take some action, you will take the action here. And finally there is a finally block also. This will be, whatever happens, this will be always executed. That means if I manage to open the file, then the file will be automatically closed. Okay, and it seems that if I fail at right here itself, it will still try to close the file, which is bad. I should have checked if the file is open, then only close, which I have not checked here. So I can uh, check if the file has been opened. Okay, this is important. Otherwise, f dot close, if f doesn't exist, f dot close also will not really work. So the first line, so this should be checked. Other than that, something may go wrong. That means you may have empty lines. Okay, you may have lines with only one field and so on. All of them can be taken care of and they will come here. And here when it comes, you can actually say there are rules. You can simply say that raise. That means there is an exception that something went wrong and I don't want to take any action here. If I say raise, it will go to the caller method. So whoever call the this function, if it is a function, it will go there and it will allow that person to take an action there. Okay, so here you can actually nest the try except. For example, I have nested it here. So I have opened the file, like in the first example, I am looping over the file, I am stripping the line. Then what I am doing is that within another try block, I am now splitting. And instead of directly putting them in a list, I could do that, directly putting them in a list. I am just, because this is for demonstration purposes, I am saying n1, n2, and n3. If you put a list, then it will not give you any error, because list is a dynamic thing, and it will for each line it will have different sizes. Okay, like here, for example, this will always work, this line will always work. But if I do it this way, for those lines where there are less than 3 fields, actually these will fail, because n1, n2, and n3, if there are 2 fields, then n1 and n2 will be filled, but n2, n3 will not be filled. And in that case, automatically, Python will know that n3 is undefined. So it will give you an exception called a value error. So exception is something which we don't discuss. It's a subject by itself. And you will find exception. Exception should not be there in the production code, because it slows down your code. Python is already very slow. And if you add also exception, then it might be even more problematic. But you cannot avoid exception in certain cases. So when you look at others code, you will see exception also used here and there. So in principle, you should try to avoid exception as much as possible if there are yes, easier and simpler way. But if there is not, then you have to use exception. And here I have overused it. As you can see, I have overused it. So here also you see that the important point is that if there is a line which doesn't have three fields, then I don't want to consider that line. So what I'm simply doing is that if that try block gives me an exception, which is a value error, it will tell me that the n3 is undefined, it doesn't have a value, then I simply continue. I simply continue because I go to the next line. I skip that line. Okay, so that this is as easy as that. And other than that, you print something. This is up to. I mean, these are logic, which this is just for demonstration purposes. So the important point is that if you really want to have a very bulletproof code with file opening and reading a file, probably you need exception. Okay, because the input file, the format of the input file may or may not remain very solid over time. Okay, so you have to make sure that your program doesn't really let's say crash, okay, or give exception because you have not handled the exception properly or the unexpected conditions properly. So you have to do that. But if if that data file is very big and there is a lot of messy stuff, of course you will not use it in a way. So you will use some tool like the data frame, pandas data frame, and so on, and there they have optimized the whole thing so that if there are missing fields, pandas can actually assign some value to that missing field. Okay, so there are ways so that instead of exception, it will know which, when you read the whole data file in memory, it will already automatically know which are the locations where the fields are missing, and it will take some action. But that is a different issue. So this is the file IO. I think we have already, so this one I have already said that you can also write Python. Okay, so that's it for the time being. I think I cannot I will stop here. Okay, and in the afternoon, as usual, I am always late, so I don't think I can cover the object orientation and then numpy. So because this module part is still remaining, so in the afternoon I will start from module, which is very important. I will show how a module can be written and how it works, and then we'll move to object orientation. But I think I'm not going to do a lot of discussion on object orientation. I will only show the very basics. That is what will be needed. The other thing will not be. And then we will see what we can do with NumPy and other stuff. Okay. So if you have questions, I can try to answer.